Our last session for the day is going to be moderated by Jenny Lee from the Royal Society of Chemistry. No, sorry, chemistry? Yes, chemistry. Sorry. Sorry, I've lost my page here. Yes. Jenny Lee from the Royal Society of Chemistry will moderate our session, New Ways of Counting Researcher Contribution.
Good afternoon, everyone. So as Melanie mentioned, I'm Jenny from the Royal Society of Chemistry, and I hope you had a good chance to have some discussions during the roundtables, which I think helped set up some of the topics that we'll discuss in more depth during our panel today. And so I'm really excited that SSP enabled us to bring together this panel across different stakeholders. And so you'll hear from researchers, funders in policy, and librarians with diverse perspectives to discuss this topic of new ways of counting researcher contribution. So as a brief introduction, we're all really familiar with the phrase publish or perish, and it's been around for decades, but I think that it still motivates many researchers today, especially in the context of career advancement and even in funding decisions. And so we know, obviously, that this is an exciting time in the landscape, and there are a lot of changes happening, and new initiatives and organizations that are emerging to meaningfully count these outputs, recognize researchers for their work, and also allow them to gain credibility in a more granular and transparent way. And so this is happening on a few different levels. So one, in terms of individual attribution of a single work within a team of co-authors, and that can be described by credit that we're going to talk a little more about later. And there's also the level of an individual researcher's body of work, which can go beyond publications, as evidenced by the appearance of new preprint servers in different disciplines, and also data publishing as just a few examples. So in addition to triggering implications about reproducibility or identifiers or discoverability, I think that this really leads into thinking about what constitutes impact and how can our community of stakeholders anticipate these changes and collaborate in line with what the community needs towards shared goals. So for the remainder of the session, each of the speakers will give 15-minute highlights, and then we'll have time for questions. But except after our first speaker, we're going to have a time for a couple of questions to make sure that all the travel plans go smoothly. So I want to give enough time for questions, so I'll keep the introductions brief. But it is my great pleasure to introduce the panel of experts who are going to share updates from their latest work in the area. So first of all, we'll have Vincent Lariviere, and he's an assistant professor in information science at the University of Montreal, and also the Canada Research Chair on the transformations of scholarly communication. And he's going to share his in-depth analysis from a few publishers using the credit taxonomy. Greene is an assistant professor in computational biology at the University of Pennsylvania, and he'll share more about his personal experience with non-traditional outputs. And sitting next to him is Kristi Holmes, who is the director of the Galter Health Sciences Library and associate professor in bioinformatics at Northwestern University. And she's doing research on attribution beyond publications using bioinformatics approaches and research impact. And Dina Paltoo, finally, is the assistant director for policy development at the National Library of Medicine, and she'll talk about interim research products and policy updates, and also from her former perspective as the director of scientific data sharing policy at the National Institutes of Health. So thank you, and let's get started with Vincent.
Okay. Thanks for that. Thank you for the invitation. And so what I'll be presenting today is a preliminary analysis of the data that we've got from PLOS, from the Public Library of Sciences, on the credit taxonomy. And this is done in collaboration with my colleague Cassidy Sugimoto at Indiana University. So before analyzing that, let's think through what are the main functions of authorship. So Birnholtz in 2006 wrote what I believe is an important paper that clarifies what functions authorship serves in today's scientific community. So of course, the first thing is that it assigns the credit for discovery. So you've discovered something, you get the credit for it. But the flip side of that is that it attributes for you and for the co-author the responsibility for the work that has been done. And this credit and responsibility, but mostly the credit aspect, allows for the existence of an economy of symbolic capital, an economy of your reputation. So you've wrote papers, you've discovered stuff, therefore you have more scientific capital, which can allow to attract funding, students, etc. Now, this is kind of this was well understood by people before, but there's been quite a few transformations of authorship over the last mostly 30 years. First, there's been a crazy increase in co-authorship, and it's not really clear whether this is actually due to an increase in collaboration or in more loose authorship attributions criteria. So in a way, we're multiplying the capital, so more and more people get the capital for scholarly papers, but we're actually, in many cases, dividing the responsibility, so it's not very clear who has done what on a given piece of papers. And just to illustrate that, here's the mean number of authors per paper in the natural sciences and engineering over the last 100 years. So basically, started for about one author per paper, and you see that until the 1970s, it increases, but not as fast as after the 1970s, where basically we see an exponential increase in the number of authors per paper. Of course, in math, things are a bit different, but it's a bit more difficult to divide the labor in that field. We see the same thing in most fields of the social sciences. So collaboration is not only something that is seen in the natural sciences and medicine. You see that quite a lot in the social sciences. The only fields where the individual authors, who then, of course, gets all of the credit and responsibility, can be observed, is in the arts and humanities, where still we kind of see a little increase, but that's quite marginal. In parallel with that, we've been seeing an increase in unethical research behavior, or at least we've been finding more. So do we find more because we search for it more? But in any case, we see an increase of these retractions for many unethical reasons. And part of them are, of course, issues with authorship, so be it either gift authorship or ghost authorship. And in parallel with that, we're increasingly scrutinizing what researchers have been doing. There's been also, in order to kind of clean the house a little bit, a few authorship criteria that have been proposed. The most well-known one is, of course, the International Committee of Medical Journal Editors, where authors have to kind of guarantee in some way all aspects of the world or all aspects of the work, while the World Association of Medical Editors understands that some authors might have specific contribution and therefore cannot necessarily guarantee or at least be accountable for all of the aspects of a piece of work. So, and that's quite an interesting figure. So that basically compares the evolution for both medicine and engineering, the evolution in the number of authors per paper, and the evolution of the number of inventor per patent. And what we see is that researchers seem to be granting authorship at a speed that is much faster than for patents. And what's the reason for that, you think? Money, voila. So, of course, you can share authorship because you don't really get money with that. But when it comes to patents, well, I might want to restrict the people that would have access to that pot of money. So that kind of shows that there's different criteria for attributing authorship and inventorship. Which brings us to contributorship statements. So basically, contributorship statements were created in order to come up with more precise contributions for scholarly authors. So PLOS started with 5 main contributions that they've used from 2003 to 2016, where basically things were broken down into either you've analyzed the data, you've made the experiments, you've conceived and designed the experiments, you wrote the paper, or you contributed reagents, materials, tool, which is kind of a very loose category. That division of tasks was considered not to be very precise, and so there was a task force about 5 years ago that was created in order to come up with more precise contributorship statement, and this is what led to the credit taxonomy that we're going to look into here, that basically divides contributions into 14 different tasks that can be made. And so in the case of PLOS, each author, so to be an author, you need to have done at least one of the contribution. So this is how the old taxonomy looked like. What you have on that slide is basically the 5 tasks, and then the proportion of authors that have done this task according to their order in the byline of the paper. And what you see basically is the typical U-shaped curve, where basically first author have done more than middle authors, and last authors in most cases have done as much or participated as much to a given task than the first authors. So that's already interesting. It already leads to a few insights about how labor is divided. But we'll see that with the credit taxonomy, we get to things that are, in my opinion, much more interesting. So what data set did we get? So basically, we got the XML data dump from PLOS. About 15,000 papers were processed for this analysis. PLOS Biology only had 1 paper in the set, so we basically removed it. And of course, most of the papers are from PLOS One, which is of course the biggest of the PLOS series of journals. We do see that there's some variations in the mean number of credit contributions per paper. Some are around, it's not very clear here, but some are around 11, some are around 10. It's not very big, actually. The difference is not that big, but what's most important here is the differences in terms of mean number of authors per paper. So from basically 5 authors per paper in PLOS computational biology to about 15 in PLOS medicine. So not all journals are similar in their mean number of authors. So first result, so proportion of papers that have a given credit taxonomy. So unsurprisingly, a paper needs to have someone writing it. So most papers, not all, but the vast majority of papers have someone that have done that work, which is very reassuring, I believe. The rest were probably written by machine learning algorithms or something like that. So the main task is this one, and then of course, reviewing and editing. So almost all papers have that. Almost all papers have a conceptualization, and then you see formal analysis is something that is a bit less important. And at the bottom, you have resources, validation, visualization, and software, which is not necessarily present in all of the papers, especially the software part. So this is just looking at the level of papers. Comparing by journals, well, we see that basically investigation is much more present in PLOS genetics. PLOS medicine as, let's say, the top 5 are almost in all paper, but then it drops pretty quickly. But by and large, you see that in general, we see kind of the same patterns across the PLOS spectrum of journals. Now, what's very interesting is to look at the proportion of authors that have done a given task. And this is very interesting. So what you see on top is that around 70% of authors have reviewed the writing. So there's a 30% that did not really look at the writing. Not that they did not write the manuscript, but they did not even review it. But that's the task that is the most present, or that is the most often assigned to an author. Then we go to methodology, which is at about 55, and then very quickly you see that from conceptualization down, less than half of authors have performed a given task. And so if you look at writing, which is the task that, of course, is present on almost all papers, only 40% of authors have actually done that task. And of course, funding acquisition, which is typically done by the PI, and there's typically only 1 per paper, is the contribution that is the most specific, that is done by the lowest proportion of authors. Now, by journals, again, we see slight differences. Again, a striking difference for me is in the case of PLOS medicine, around 95% of authors have at least done some writing, while for PLOS One, it's about 55. Does anyone has an idea why this is happening? Okay, so PLOS medicine has to follow the ICMGE criteria, the International Committee of Medical Journal Editor, which means that everyone needs to have done some writing a bit. So they basically check the box for everyone. And we'll go back to the limitations of these contributorship statements because, of course, they are self-declared. This is not something that comes up of a let's say, of a higher authority. Each PI basically assigns the contribution, and of course, those might be accurate or slightly less accurate in some other cases. We also see what's interesting there, of course, PLOS pathogens as a lower proportion of authors that have contributed to funding. In the case of PLOS pathogen, again, this is a very interesting case because that's the only journal where investigation is actually the task that is performed by the highest proportion of authors of these papers. So again, it shows a few interesting bits about how disciplines work and how work is being divided in those various subfields. Now, of course, as a function of the number of authors, so when you have only one author, of course, that author has done all of the tasks, and then you see that some tasks are more divided than others, which remain relatively stable as a function of the number of authors. So, of course, writing, the review part and the investigation part remains a bit more stable as a function of number of authors, while on the other hand, project administration software is stuff that the more authors you have, the lower proportion of authors in the end will do this task. Which brings me to what I think is probably the most interesting slide, but it's a bit tough to understand. So do you hear me well when I talk like that? Okay, so I'll do it like that. We can't hear you. Okay, yeah. That's a good idea. I hate to be that strange. Okay. Un, deux, voilà. Okay, so what you have here is basically co-contribution. So what's the proportion of those that have done visualization that have also done the writing? And this is not a symmetrical thing, because in 82% of those that have done visualization have done the writing, but on the other hand, 76% of those that have done the visualization have done the, no, it's on the, okay, it's 57, writing, review. 90% of those that have written the original draft have also edited the one. So it shows kind of the asymmetry between the tasks. So of course, again, here, everyone almost does review and editing in collaboration with other tasks, but then those who do review and editing don't necessarily do the other tasks. So it shows kind of the asymmetry in the various tasks that are performed by researchers. And again, trying to compare this result with the result that we've obtained with the other typology, we see again the inverted U shape, but in a different manner. So basically, while writing in the other typology was performed in an even manner between first and last authors, when you look at who writes the original draft, it's typically the first author, not the last author. And by a sizable margin, basically more than 90% of first authors do the actual writing. It's less than 50 in the case of last authors. And then, of course, review and editing is more performed by last authors than by first authors. So this has implications for bibliometrics. When we actually attribute papers to people, we see that using author's order kind of give you insights about what are the tasks that are being performed by researcher. And so basically this is sorted out by proportion of a task that is done by the first author. And you should, so at the bottom, project administration, providing resources, funding acquisition, supervision, are tasks that are mostly performed by last author rather than first author. I will go on your side too, because otherwise it's not very kind. And so once you have that, so of course it gives a lot of insights about how research is being done, but we can also analyze some gender patterns, and this is more of a research result type of slide. So with the previous PLOS analysis, we wrote a paper that basically showed that male were more likely to write the paper. So there was a big gender gap in the tasks that were being made by male and female. So basically, female were doing the experimental work, and male were doing the conceptual work, and among those, mostly the writing. And what you actually see when you break down writing into doing the review and editing and doing the original draft, you see a shift between what male and female do. So in the end, female are much more likely to do the writing, to do the original draft. But on the other hand, male are more likely to do the review and editing, which is the more, let's say, senior task. We see a similar trend in terms of conceptualization. So male are more likely to do the conceptual part or contribute to the conceptual part, while female are more likely to do the investigation, so to do the actual manipulations in the lab. Same for supervision and funding acquisition, and actually most of the other tasks that are more senior, more admin, are more likely to be done by men. And this is coherent with what we found in the other typology, only it's much more precise in terms of the tasks that are being done. And last slide, a few limitations about those contributorship statements. So of course, as I've mentioned, those are self-declared. When you look at data by discipline, you see that physicists are basically doing all the tasks. So in the physics data, you see that basically all of the authors did everything, which of course, thanks, we know to be wrong. But it's of course physicists have had a history of having more socialist behavior, signing in alphabetical order and stuff like that. And so that reflects, it is reflected in the data. From an indicator's point of view, none of those are actually indexed in any databases, be it from Dimensions to Scopus to Web of Science to Google Scholar. This is something that is part of the paper that should be indexed at some point, but it's not there yet. But there's some use to them, especially in cases of misconduct, where actually you're able to understand who has been doing what. And in the end, unfortunately, it has not been picked up by so many journals. There's a lot of journals in medical sciences that have picked that up, but very little in the social sciences and humanities and natural sciences. And again, this should probably increase over the next few years. A lot of journals are understanding that this is something important, but we're not there yet. So thank you very much.
Take some questions for Vincent at this point.
Yep.
Just a quick question. Do we know how many journals have actually picked up? Do we know how many journals have instituted this?
I don't have exact numbers, but I think, again, on top of my head, it's like maximum a few hundred. So considering that at the world level, according to Ulrich, there's about 130,000 scholarly journals at the world level. Of course, like the main databases index about 25 to 30,000 of them, but it's a minority of journals.
Thank you.
Yeah.
I was just going to clarify on that. I know that so I'm with Science Magazine. We're working on adopting credit, but I think there's some things with like, there needs to be a new version of JATS in order to be compliant with credit. So I think that could be a limiting factor for more journals not adopting them.
Yeah.
That version that involves credit is, that version is set for approval, so it will be available very soon.
There's a question there.
So I have two questions, actually. I'm Stephanie. I'm from the American Chemical Society. One, will that PowerPoint be available somewhere publicly at all, or would you be willing to share it?
Yeah, I'm willing to share it.
Very
no
interesting.
Problem,
And two, I'm wondering about the gender data. How did you determine if names were male or female, and did you only do that for U.S. authors?
So we've developed in 2013 a gender assignment algorithm based on roughly 1 million names at the world level, and it has a geographical dimension. So let's say they give a name Andrea in Italy is a male, while in most countries it's female. So it's publicly available in the sense that anyone who wants it, I just send them the list, and so we've used that in a paper on that in 2013 that has had quite a lot of visibility. So it's based on names basically, and for this data, if I remember correctly, we're able to assign about 93% of names with a gender.
Yeah, because I know we've attempted to do something in the past, and with Chinese author names in particular, it proved to be very difficult, and it was hard to come up with a good percentage that
I'd say it's
actually match?
catastrophic, actually.
Okay.
Yeah.
Thank you.
Yeah, because of the transliteration, of course. So if it were the Chinese name, it'd be easier. But if you have the transliteration, then it can go, I'd say, both ways. Yeah.
Great.
Thanks.
Should there be something on the screen? Oh, escape.
Yeah, yes, always escape.
Which one's next?
Greene, probably. There we go.
This one?
Yeah. Okay, so I'd like, if you're interested in these slides, these should be available. I'm happy to send them to you. I think they're also going to get distributed. So I'm Casey Greene. I'm here today. I'm an assistant professor at UPenn. I also run something called the Childhood Cancer Data Lab for a funder, which is Alex's Lemonade Stand Foundation. But what I'll tell you is at least my personal opinion and not the positions of these other organizations. So I'm going to talk a little bit about, I guess, 3 things that we've done focused on credit. So one is a manuscript that we wrote in a way that I think is a little bit innovative, where we were able to assign credit down to the word level for individual contributions. The second thing is an attempt to recognize people who do something that's under-recognized. And then the third one is sort of an approach to publishing that we've been playing around with. And they'll be very short, so you can ask questions later if you want. So about 2 years ago, I ended up I was first invited by Journal of the Royal Society Interface to write a headline review. And I was like, well, I don't really want to write this review. That's a lot of work. So I tweeted and tried to get other people to write it, which turned out to be way more work. So we created this GitHub repository, and we just invited people to contribute. And it was really interesting to see people come together. So they ended up discussing papers that had been published. I think there's now like 900 different GitHub issues where they discussed papers that have been published in this field of deep learning. This is actually still active, even though it's been published. You can go to the GitHub issues and actually see people talking now about the deep learning literature. It's kind of wild. We did end up actually writing the paper, which is better than sometimes we do. You'll notice there's a lot of ORC-IDs on that table, so ORC-ID folks, we did a good job of getting 40 people to register. And we did, the thing that we usually get questions about is the author order was determined with a randomized algorithm, which is actually, we did this sort of pre-registered study design where we said, here, we're going to assign authorship order in this way. So we divided people into 4 tiers, and then we randomized order within those tiers using a predefined seed. So it was kind of an interesting process. So we probably break your taxonomy, but we do what we can to make life difficult. So this is sort of how the authoring went. So this is actually number of words contributed by authors. And number of words is sort of includes additions and removals, so just changes. So we were actually invited to write this back in June, I think. We really started putting the repository together in August. The first words actually got committed to the manuscript text in around mid-October. And it was due in January, so January 2017. So you can see how we did on that front. So this is the first deadline. I think the second deadline's somewhere in here. So you know, if you've ever asked authors to review something or write something, that usually the third deadline is when you actually get a response. So the third deadline was in here. So this is actually the first draft of the manuscript. And so really Tony and I kind of started writing, and then just other people kind of jumped on. This is a subset of the authors, just broken out by number of words that they contributed. As well as, you know, sort of just when they started contributing. So the more recent editions are further to the right. And so we wrote this. We had a lot of fun writing it. It was exciting and entertaining. And then at the end of the year, so we put up the preprint last year in June. Oh, I should go through the rest of the authoring process. Papers under review. It turns out when you submit a manuscript that's 102 pages, your reviewers take a long time to review it, which we understood and did not criticize them for. And so we got the reviews back, I think, in near the end of the year, so sometime in the sort of, I think, November timeframe. We ended up revising it and resubmitting it at the end of January, and then this is actually the version that got published, so this one here. And so I was reading Nature at the end of the year last year, and they had this 2017 year in review, the science events that shaped our year, which was pretty cool. There were a lot of interesting things there. And then the thing that really was exciting was we made it to this table. It was exciting for us, probably less exciting for other people, which listed the most read preprints or most downloaded preprints, got to be specific, of 2017. And we ended up making it on this list. By the end of the year, our preprint had about 20,000 full text downloads. And then between the preprint and the published version right now, we've had about 70,000 downloads. So it's, it's at least been somewhat read. Well, it's been downloaded. I made the mistake of asking I was giving a seminar, and I made the mistake of asking if people had downloaded it, and all the hands went up. And then I asked if people had read it, and only 2 hands remained up. So no one's reading it, but everyone's got it on their computer, so at least there's something. Oh yeah, so this is the download and alt metrics. So this was as of January. I just saved this when that Nature article came out. So I guess we were in a 25,000 PDF download. And then this is as of last week. Actually, one of the strange things is that people keep downloading the preprint, even though there's a link at the top that says this is published elsewhere and you can actually get it formatted. But the preprint has had about 40,000 downloads, and I can't read this on here, but 20-something thousand downloads of the full text. Anyway, it's been somewhat read, or at least downloaded. So a different thing to chat about. So a couple years ago, the New England Journal of Medicine published an article, I guess almost 3 years ago now, that talked about people who reuse other people's data and use the term research parasites to refer to them. So I didn't like this very much. I much prefer the definition of scientist from Newton and Hooke. Well, from Newton to Hooke, which there's a lot of backstory to this quote, but basically, if I have seen further, so right here, if I have seen further, it is by standing on the shoulders of giants. So to me, this is more of an accurate view of how science works than the idea that people who use other people's data are parasites. I think probably this is more accurate. But in any case, we decided to, this is the paper from the New England Journal. They talk about this horrible group of people who use another group's data for their own ends, possibly stealing from research productivity planned by the original investigator, planned by the data gatherers, or who even use that data to try to disprove what the original investigators had posited. Oh, the humanity. God forbid should someone do good science. So then they talk about these sort of people being research parasites. So we started something called the Research Parasite Awards, which I kid you not, I put up a thing on my lab website, and I was like, we're going to give out the Research Parasite Awards. And it was sort of a joke, but we were definitely going to do it. And then it's one of the few times someone just came and offered us a bunch of money. And so now there's an endowment. So as long as Penn's endowment exists, there was an endowment for the Research Parasite Awards. So every year in January, we give these things out. So if you're interested in receiving a Research Parasite Award or nominating someone for a Research Parasite Award, go to researchparasite.com. And you need to nominate them soon because the application is due in 5 days at 5 p.m. Hawaii Standard Time. The award ceremony is also held in Hawaii in January. So parasites, we do have a good time. And then finally, recently, so this year, a group of, I and a few other people started something that was an attempt to take advantage of preprints to do something a little bit different with peer review. So we were getting tired of the fact that we would sometimes review papers at multiple different journals, get essentially the same paper, and it returns to you essentially unchanged because the authors expect there's no way the same person will review this paper again. Sure enough, there's not that many people who can review it, so it comes to us again. And so, what we wanted to do was create a forum for the peer review to be open and public, even if the papers themselves end up published somewhere else. So the review is sort of a living kind of work product that also gets discussed and read and puts the paper into context. And so around this, we had the other challenge that no one was ever going to submit a paper to us, because why would they possibly do that? That would be insane. So instead what we do is we just review papers that are put on bioRxiv, or actually now published papers. So we've had one paper that was published in the time between when we sent it out for review and when it came back, and we still posted the reviews. And I think our reviews must have been more stringent than the journal, given that it got published. So this is what it looks like. So Stephanie Hicks here is the associate editor in this case. So she sent this paper out for review. So this is the paper. It's this preprint from Ali Stegel's lab. She talks about why she sent it out for review. She talks about basically what the reviewers found, her interpretation of what the reviewers had to say. The review reports are also published. So this is from David Risso, who decided to be named, who was one of the reviewers of the manuscript. And so, if you're a journal and you're publishing and you're like, wow, where can I find papers that people think are interesting that someone has already gone to the trouble of reviewing for me? We have that available for a limited number of papers. But if you think about sort of where publishing could go, I think the idea that the review process is somewhat separated from the publication process could actually be beneficial for both science and also journals having people turn them down to review is a lot of person time goes into that. And so in this case, these are people who've already reviewed the paper, so you could take the first round of reviews, ask those reviewers to review it again, and send it back out after the authors revise. So I think there's potential benefit there. And then, okay, so those were the 3 quick vignettes. I'm happy to answer questions. I have a great lab and group of people both in my lab and at the Childhood Cancer Data Lab who make this stuff possible, although today the stuff I talked about was more kind of meta, although a number of the people on the Greene Lab did actually help to author that paper. Thanks.
So hello, everyone. I'm a Mac user, so please be patient. Okay, great. So thank you very much for the opportunity to join you all today. The conversations earlier were really invigorating and exciting, and so I'm pleased to be on the panel with such esteemed colleagues. So I'm going to talk to you a little bit today about some of the work that we've been doing trying to understand this idea of credit and attribution in scholarship. And we'll be putting it in the context of biomedicine because I am at a school of medicine. So just to set that context up for you. So I'll be sharing with you a little bit about how biomedical research is evolving and how institutions are meeting some of these challenges with this evolving ecosystem, certainly looking at publication data, and then what else exists beyond publication data, and then finally some ideas about ways that we might be able to move this work forward. So the context here, we're really looking at this idea of translational medicine that I am affiliated with Northwestern University Clinical and Translational Sciences Institute. Basically, the quick take on translation is we're really looking at what kinds of activities, services, resources can be put into place so that knowledge, that experimental process that's happening in basic science can be translated to result in improved health of people and our communities for benefit for all. And so there are a lot of things in place here. It's services, it's how do we function as teams, it's things about communication, continuous improvement, and so on. So as we talk a little bit about how biomedical research is changing, I think probably all of us are familiar with this idea of the research life cycle. There's a research life cycle for every human on the planet, I believe. This is a schematic, but you're looking here at some of the different things that are happening as part of the research process. And one thing that I think is particularly interesting is that there's been such excitement and more attention spent toward open science, open data, research reproducibility, and so on. And that's because there are very real take-home benefits for thinking about science and the research process in general in open contexts. So we see increased speed, efficiency, accessibility of research results and knowledge. The fact that research knowledge can be translated more longitudinally, and also there's that reproducibility, that rigor sort of context where we can look at increased and enhanced quality of research. So a great amount of effort in my group is spent thinking about what research impact is and what it means. So research impact isn't the number of citations that a paper has, but what you can think about are outcomes. So, is there improved health? Is there a new standard of care? Is there a new protocol or so on? So the real changes in how things are being done. So you can see here there are a couple of definitions of research impact. While I am partial to the way that NIH looks at research impact and its impact on health and society and knowledge in general, I do like this Australian Research Council definition because it's really taking it to a much broader perspective where we're looking at economy, society, culture, national security, public policy, and so on. Because I think that that's something that does certainly impact all of us in all aspects of our lives. One thing that I do want to point out here is that when we think about the individuals who are involved in the research process, often we think about those individuals in the lab, the PI, the graduate student, the postdoc, and so on. But what we really need to understand is the types of people and the types of work that are happening are all critical to move research across the finish line. So there are a number of individuals that are making seminal contributions to the process. However, they are not represented in the research outputs, so through authorship on a paper. People like clinical research coordinators who are consenting patients for clinical trials. Many of them will not end up on that author list, but if you have someone who's very good at working with a sensitive population, let's say pediatric patients, and working with the family to consent them for a clinical trial, that is an incredible contribution to that research team, and it is invisible right now. So as you can see, I've listed a couple of things here. There are lots of different things that are created. Measurement instruments, quality measure guidelines, cost-effective interventions, all of those things are not represented in a machine-readable way. And so my question to everyone here, and just in general, is what can we do to put infrastructure in place so that we can better represent some of these ancillary products in the context of this research space? So one of the things that we're doing at Northwestern, we have a team scientist faculty track. This team scientist faculty track was established in 2015, and this is publicly available on our website. And what this does is it actually allows us to better represent those individuals who are working in a collaborative fashion, who are contributing to infrastructure, and it provides a way of representing those contributions in a manner that is clearly defined and that is credited for promotion processes and so on. And so this information, I've just taken a screenshot from the guideline from our Office of Faculty Affairs. And so I just want to direct your attention to that second text bar. Faculty on this track do not perform clinical work, but do contribute to the education and service missions of the medical school. While members of this track make research the major focus of their activity, for some, education might be the major focus. And it talks about the types of things that they are creating. So it's not that typical currency that we often think about with respect to promotion and tenure. So we did a survey of all of the team scientist faculty members, and we just wanted to know about satisfaction, because this is a very different context when we think about who we are as faculty members. I've got some of the data presented here, and this is basically, we looked at satisfaction. So overall satisfaction with their position. Do they have the opportunity to collaborate with other faculty? Do they feel like they're contributing to research? That their contributions are acknowledged via co-authorships? And then, is that promotion process clear and transparent? And as you can see, nearly everything has a satisfaction rating of 75% or more, with the exception of promotion process is clear and transparent. And I would, that's 68% for my fellow panelists here, who it's hard to see the slides. But I will note that I think that is a reflection, because this is such a different conversation. And so what does it mean? Well, it's new. It's only been in place since 2015. And so while we have had now people successfully move forward in all levels through that promotion process, and as that becomes more acculturated on campus, I think it'll become more familiar to all of us, myself included. So this is the track that I'm on. Something else that's a great way to think about promotion and tenure is work that's happening in the ScalComm lab, where they're looking at, they looked at promotion and tenure guideline documentation in the context of open science. And so that is just another aspect to think about the types of things that people are doing: team science, open science, and so on. And I'm not going to spend, obviously, much time talking about this, because we've had an opportunity to hear a little bit more. But as we think about credit and the types of things that we want credit for with the context of scholarship, I think it does open up an opportunity to think in a kind of broader view about the publication data. So there's already quite a bit of data that's collected and made available. We leverage a lot of it in my own group for analysis. But there's a lot of stuff that isn't here. And so this seems like a great opportunity. So certainly outputs, looking at affiliations that aren't available in the metadata, helping to ensure reliable links to funding, and that is both a mechanical aspect issue as well as cultural issue, getting people to cite the grants, things like open access status, compliance, so on, and then that idea of companion digital objects and ancillary products. So this work, we're actually doing this work in the context of the National Center for Data Health. This is a center that was recently funded by the National Center for Advancing Clinical and Translational Science. And what we're doing is looking at ways to provide machine actionable infrastructure to better represent credit beyond that publication. And here we can see we've tried to depict a research workflow of various things that go into the research process. I want to point out the gold star. This is the only paper on the map. So you can see that there are a number of things that happen. We have our funding agency giving awards. We have various researchers who receive them. We also have a programmer who didn't receive any money, but is contributing to a GitHub project. And they created software that's used by one of those researchers. It's described in the paper and so on. So how do we create the infrastructure where we can make those assertions and tie some of these things together? So this project that we have through the National Center for Data Health is the informatics of attribution. What we really want to do is look at a collaborative approach to being able to understand the requirements that are needed for systems as well as for populations to be able to better represent contribution and the types of things that we're creating. As you might imagine, not only does this require technology, but it absolutely requires the use of persistent identifiers. So our friends at ORCID are an important part of this. But there are a number of other persistent identifiers, grid ID looking at institutional affiliations, some of the accession numbers for biological molecules and things like that. So there are persistent identifiers everywhere, and they are definitely our friends. We need data models, and then we also need the people to be able to tie all of this together. So this is a project that I've been working on with Melissa Handel. Actually, we've been thinking about it for quite some time, but really only in the last couple of years have we even imagined that this is possible to take forward, and I think that there are a couple of reasons why. So certainly it's easier to get data and interact with data in a meaningful way. I think the research information systems have gained a particular sophistication in terms of the type of data and the way they're able to integrate with other institutional systems. We have this terrific diverse biomedical workforce, thinking about biomedicine again, where we have all of these different roles that are all part of the process. Team science is, of course, an important aspect of that. Looking at these different kinds of activities that people are doing, a much greater emphasis on evaluation and continuous improvement and reporting. So you're seeing that globally, certainly, but we're starting to see it here in the United States even more. And then finally, I think people are just ready for it. You know, there's just been a lot of enthusiasm about it. So with the risk of issuing a call to arms, I'm going to suggest that if anyone would be interested in talking more about it or being part of the conversation, we have a sign-up, a bit.ly attribution sign-up link, and so we'll be starting the conversation. We'll be having a number of workshops and other kinds of activities to get involved, and we certainly welcome your interest, or if you just want to stay in touch and find out what's going on, we'll be happy to do that. So I did want to point out a couple of things. So, you know, some of the things that are necessary for this kind of project to move forward, it's cultural and it's technological. So we need smarter systems, we need good data, we need to be able to reuse and interoperate across systems. The persistent identifiers, which I mentioned, you need to have institutional or organizational cultures that are ready for some of these changes and these conversations. And then being able to build on some of the strong work that's already happened. I've got a couple of screenshots here. One, the NISO, there's a recommended practice that came out from the Alternative Assessment Metrics Project, which has a number of different kinds of research outputs. And then the Becker model, which is a project that we worked on when I was at WashU. With Kathy Sarley, who led this, and Ellen Dubinsky, and it is an incredible resource and has been a great foundation for this as well. So, you know, when we think about this, what do we want credit for and what is meaningful? Sometimes what we're able to see through the standard infrastructure that's available in publishing might not necessarily be the thing, it's not the whole story. And so how do we work together to be able to uncover some of this? And so, you know, we certainly look forward to having these conversations and also getting to hear your perspectives as well. You know, and I put this screenshot here because, you know, I wanted to reflect, even though publications are certainly something that we all find important and valuable in terms of the scholarly process, there are a lot of other things that are related to those publications. And so it's a great opportunity for institutions, for publishers, for funding agencies and scholarly societies to work together to begin to tie together some of those concepts. Here are my acknowledgements. We've got a great group at Northwestern, the team at WashU, and then, of course, Melissa Handel and Mary Jane White from OHSU. So thank you.
Good afternoon. Okay, thank you for having me this afternoon. I think all of the presentations thus far will be a great introduction and a great background to some of the things that I'll share with you. I'm coming at this from a NIH funder's perspective, and a lot of what we do as far as policy is concerned is very much in the background. So a lot of it you don't hear about until we put it out there, but we do a lot of information gathering and community engagement with our stakeholders to try to figure out the best path forward. Policy is somewhat very reactive and not proactive. We don't sit around thinking about what policies we can just come up with because we want to, but we are looking to see what the needs are in the community to see what would be best. So I'm going to talk a little bit about some of the things that we're doing with preprints and interim research products, a little bit about the National Library of Medicine strategic plan, and also what we're doing as far as data sharing and management are concerned. So why are we interested in this right now? We have a very dynamic situation with the potential to advance science. We know that there's a growing recognition that interim research products could speed the dissemination of science. It can enhance rigor, which is very important to the National Institutes of Health. It can allow for record priority, a more informed grant review. If we can know where the field is going, if we can know what people have done, it can help to determine how that process will go, as well as provide some knowledge of negative data. A lot of times negative data or negative results are not published in the literature, but this information is extremely important for the research community to know about. Many disciplines have been using preprints for years, and there are many organizations that support various interim research products, such as ASAP Bio and the Center for Open Science. But this change is happening at different rates for different disciplines. Not all the fields are accepting this at the same rate. But there are also a lack of policies for citation and standard reporting of interim research products. So for the purposes of this presentation and for the National Institutes of Health, interim research products are complete public research products that are not final. This is a very broad definition, and it's broad on purpose, but it's not intended to focus on research products that are specifically addressed in other policies that NIH may have, such as genomic data sharing or clinical trials, or even some of our collections for physical collections policies. Examples of interim research products are preprints, which are complete and public drafts of scientific documents. Preprints can help speed dissemination, it can help establish priority, generate feedback on research, and also may reduce publication bias. And we heard from Casey earlier the importance and how things went with his preprint article. But pre-registration of protocols can also be important. It publicly declares the key elements of a research project in advance, such as hypotheses and measures that will be taken into consideration. It can confirm research protocols and also analysis plans, and it also may reduce certain biases. So earlier last year, the NIH released a request for information. We wanted to see what the community thought about interim research products and what NIH could do to facilitate the reporting of these products in our grant review and reporting systems. So we released this request for information on including preprints and interim research products in NIH Applications and Reports. We specifically requested feedback on the types of interim research products that are created or hosted, what are considered to be interim research products and how are they used, how are particular types of interim research products might impact the advancement of science, potential citation standards, the possible need and potential impact of citing these products in the peer review of NIH applications, and how NIH reviewers might actually evaluate these citations, and any other relevant information. we actually received about 351 responses to this request for information, and 79% of the respondents were scientists and authors. So I'm just going to briefly go through some of these RFI responses so you can see how the community felt. So for the products, the interim research products that are created and hosted, most were preprints, software code, data, protocols, some presentations. And as far as what the community felt to be considered interim research products, once again, preprints, software code, data, and protocols. Those received the most responses. We also, as I indicated, requested feedback on how interim research products are used and what their impact is on science. And in the field of the researchers that responded, they felt that interim research products could speed dissemination, enhance rigor, allow for repositories. They could serve as a substitute in some cases for peer review, support reproducibility, and so forth. And as far as the impact on science, overall, the respondents were pretty supportive, but they also felt that the impact could enhance rigor, increase transparency, establish priorities, and also allow for the dissemination of negative results, which we mentioned earlier. But there were a few respondents that were not supportive of interim research products. We also requested information on citation and review of interim research products, and most respondents supported potential citation standards for these through the use of digital object identifiers or some sort of persistent identifier. The indication that the preprint is a preprint. It's not a peer-reviewed journal, but it is what it is. It's a preprint. That there should be some sort of central repository and metadata and indexing of interim research products, and that they could also be used for other purposes, such as licensing or promoting the FAIR principles, findable, accessible, interoperable, and reusable. Through peer review, we received a few recommendations from stakeholders that there should be a defined interim research product. We should be able to state what an interim research product is in our definition, and that citing interim research products should be available through NIH annual reporting and also in funding applications. So several months later, after we gathered all of the data and analyzed it and considered all of the feedback we received, we came up with a policy on reporting preprints and other research products. And through this policy, we're encouraging investigators to use interim research products to speed the dissemination and enhance the rigor of their work. This is not a requirement for our investigators, but we are encouraging the use of it. It became effective in spring of last year, and it includes provisions for citing interim research products and applications, proposals, and reports, claiming interim research products as products of NIH awards, and also selecting interim research product repositories. And what we really want to promote is this idea of FAIR, findable, accessible, interoperable, and reusable. Soon after, NIH updated its Section C of its reporting, the research reporting system for annual reports and so forth, to allow for investigators to be able to report this. So I list here what is currently in the section. We have publications, websites, technologies or techniques, inventions, patent applications and licensing, and other. And so through this other category, we could allow for the reporting of interim research products. And I just wanted to mention, since we came out with this policy encouraging investigators to report their interim research products, we actually have not had as much uptake in that as we initially expected. We've had, and this is not a thorough analysis, but we've had about 400 reports so far. Also earlier this year, NLM released its strategic plan for platform for biomedical discovery and data-powered health. This strategic plan includes 3 pillars: accelerating discovery and advancing health through data-driven research, reaching more people in more ways through enhanced dissemination and engagement, and also building a workforce for data-driven research and health. The strategic plan was developed after about the release of about 5 requests for information, several town halls, site visits, a lot of public engagement with the community and our stakeholders. We really wanted to hear from everyone where the NLM should be going. And I just wanted to highlight a few things in this report. In Objective 1.1 of the strategic plan, we have this objective which reads, NLM will stimulate new forms of scientific communication and become the library of the future, one of connections between and among literature, data, models, and analytical tools. Creating efficient ways to link the literature with associated data sets enables knowledge generation and discovery. And this is why we want to link the data. Additional goals also include leveraging our National Center for Biotechnology information resources to provide users with new ways to deposit, find, access, and reuse data if appropriate, and also to support overall NIH efforts to enhance rigor and reproducibility. So I wanted to provide a current snapshot of the data that's currently in PubMed Central. About 20% of the articles in PubMed Central have associated supplementary material, a data availability statement, or even a data citation. Once again, this is not a requirement for our articles in PubMed Central to have this, but we do allow for it and encourage it. And these are very small data sets. These are not large data sets like what we have in some of our genomic repositories. But the challenge has been inconsistent or non-existent policies on how to make the data available and cite it at the funder and journal level, which can result in inconsistencies in data association practices. The current scope of PubMed Central is funded, peer-reviewed author manuscripts accepted for publication in a journal, and also publisher versions of the record and final published versions. So we currently do not have preprints in our scope. We have not necessarily been adding preprint records to PMC or PubMed, but as a part of our current strategic plan, we are making a commitment to supporting new developments in scientific communication, such as preprints, and also novel alternatives to the journal issue as a mode for organizing articles. So there are many future directions also in line with this, including data citation in PubMed Labs, exposing data in PubMed Central, how can we provide the links and information related to those articles, linking publications to data in My Bibliography, which would allow for everything to kind of be found in one place and would allow for easier reporting for our investigators that we fund. Medline 2022, which will provide curation at scale, expanded metadata, and also allow for efficient and connected systems. There are other efforts ongoing. I'm not going to go into much detail with this. We know there are many international organizations who are supporting preprints. And we also have various federal activities which are not only encouraging interim research products, but are also encouraging incentivization and also credit. There is a White House Office of Science Technology Policy Interagency Working Group on Open Science, which has been working for some time to determine how to facilitate increased public access to both publications and scientific digital data. And NIH also has its priorities and policies for data stewardship. A few months ago, the NIH released its strategic plan for data science. The strategic plan was actually requested by Congress, and in the strategic plan, NIH indicates that it will modernize the data resource ecosystem to increase utility for research, enhance data sharing, access, and interoperability, and also modernize infrastructure, increase capacity. There are actually 5 overarching goals to this strategic plan, and I wanted to just mention a little bit about the last one, Goal 5, which is to enact appropriate policies to promote stewardship and sustainability. As I mentioned before, our practice is always to reach out to our stakeholder community and learn from you the directions that NIH should be going. We also released last year, or toward the end of 2016, beginning of 2017, a request for comment on establishing NIH priorities for data stewardship, specifically data management, sharing, and citation. We had 3 sections to this request for information. One was on data sharing strategy development, which really involved the what, when, hows, and whys of data sharing and management. What's the value in sharing different types of data, and what are the barriers or challenges to overcome the sharing? In Section 2, we wanted to learn more about how we could include data and software citation in our reporting system and grant applications, to learn of the impact of these citations on the reporting, what technical guidance could be provided, and also how to strengthen and incentivize data and software sharing, as well as general feedback. So, summary of the public feedback. We received about 95 responses from national and international stakeholders on this, most of which were scientific investigators performing research related to data derived from human subjects. But for data strategy sharing development, the community was generally supportive of data management and sharing and felt that NIH should move forward with some sort of policy development in this process, but felt that data underlying or supporting a publication, dissertation, supplemental materials, or any sort of dissemination of whatever is what should be shared. That the data should be made available for secondary research purposes for a minimum of 10 years, which is standard in some scientific communities, and also establish a culture of sharing that would incentivize and encourage data sharing. And as far as including citation of data and software in our reporting, the respondents felt that this should be done as long as it was conducted as a mean to incentivize researchers to share data, which would then allow investigators or enable them to receive appropriate credit or attribution for their work. And also that it's very important not only to cite this, but that's important that there be versioning of the data sets and software when generating these citations so people know what they're using, and that if they're combining data or they're looking at data and other purposes, people will know which data set it was that was accessed. Okay. So what are we doing now? We have an overarching data sharing policy from 2003, and yes, that was a very long time ago. And we are trying to figure out the best way to update this policy. Right now, it really only applies to applications that are requesting funding in over greater than $500K in direct costs in any one year. But how can we really expand this broader? We also have some specific policies that apply to other sorts of data. We have clinical trials, results reporting, and genomic data sharing, and our Cancer Moonshot initiative also requires sharing, and so forth and so on. But we need something that would apply across the board. But one of the things that we've been having problems with is actually the definition of scientific data. Because NIH funds such a vast array of scientists from so many different disciplines who are generating so many different types of data, it's actually been difficult for us to come up with a definition that could apply to everyone. We need to figure out what the scope and applicability of a policy would be, as well as how this would align with existing policies. And so some of the things that we're considering at the NIH are requirements for data management and sharing plans, whether or not we can actually require data sharing that's consistent with that data management sharing plan. What sorts of resources will we point people to? Existing repositories, what should we come up with some sort of basic criteria for these repositories that investigators should look for before submitting their data to? And how can we advise people on how to budget for data management and sharing? Also, compliance and enforcement is also a consideration, and we want to make sure that people are reporting and citing their research products, data in this case. But of course, anything that we come up with, any sort of policy that we come up with, will have a lot of implementation considerations that we will have to go along with it. So what do we need to do to get there? We need to evaluate the relative value of data sets. There's an upcoming National Academies roundtable that's going to be on forecasting costs for preserving, archiving, and promoting access to biomedical data. This workshop will inform the Library of Medicine how we can forecast these costs and consider the economic implications and also metrics and measures to determine the success and value of data sharing. We also need to consider how we can encourage citation and incentivize researchers so that researchers will want to share the data and not do it because there's a requirement or because they have to, but that they can really see the benefits in sharing and managing the data appropriately. We need to consider both policy and implementation aspects of any way forward, and also we have to continue to coordinate and partner with other funders and research organizations. And our overall goal, as I mentioned earlier, is to promote what is fair, findable, accessible, interoperable, and reusable. Thank you. Do you want me to close these? I can close them all.
All right, well, thank you so much, everyone. I thought it was a really great panel with very complementary perspectives. And I realize that we don't have all the stakeholders represented here, so we would really welcome your perspectives, and I'd like to open it up to questions.
Hi. The information on author demographic data sort of brought up some questions. As we start collecting more data on the individuals who contribute in different ways to papers, and we maybe find some glaring things where only Western authors are primary authors, or women are the one, females are represented only in the sort of data gathering, not primary position. At what point do we think that it's an opportunity to sort of put our thumb on the scale and make changes there? Just curious. I don't know how that would be. Is that a question?
That's a question for us.
So it just sort of also brought to mind the woman from Northwestern. I'm sorry, I'm forgetting your name. Yeah. I know that there have been some hospital groups who have been seeking to, so like if they're finding that there are more women, for instance, who are taking certain education tasks within public health that might not be tied to increase in pay, they're offering voucher systems or things like that. Do you think that Northwestern, with the team science, do you think you're seeing more women participating in that, and is there money tied to those tenure opportunities?
Okay, so I can give some perspective. I cannot speak on behalf of Northwestern leadership, so just take what I say with a grain of salt. I will say I think that having a more open-minded approach to understanding what people's typical workflows, what is it that people are doing at work? What are they creating, and what is the value there? And providing some sort of infrastructure to be able to identify it, acknowledge it, and credit it is actually a huge thing. So I just my own perspective, we used the credit taxonomy and built a contributor role ontology and integrated it into a research information system. And people could self-claim their roles on all of their research outputs. It was if you had an ORCID ID and it was anything with a DOI, you could assign these, kind of claims. But I actually used this initial structure to fill out my critical references form for my annual report from the Department of Preventive Medicine, because what it did was it allowed me for my, I had a data model and a paper. I mean, I'm a library director in addition to I don't write a ton of papers, you know, so I have other things that I'm creating. And what it did was it gave me a framework to be able to talk about what I contributed to each one of those projects and what my role was. So, I mean, I think just even giving people the tools to be able to assert that they have been part of something and to be able to sweep some of those things up into something that's recognized by the institution is a huge thing. I have not seen any money associated with that, but it is great because we do have you know, folks who are biostatisticians or something like that on campus who are critical to having good science happen. At least there's a way to move forward as a regular faculty member on campus. So.
If I were going to say something, I guess I'd say that I think data are helpful, but you know, we have data from lots of other fields, and that women are compensated less for the same work, and you know, data doesn't seem to necessarily drive policy. I think as a society we just have to decide this isn't acceptable. And so I hope data will help, but I don't think it's going to be the sole answer.
That's a good answer. It really kind of gets to the heart of the matter.
All right, I have some broad-ranging questions, if nobody has anything in between.
I think we have one here.
So my question is specifically for Casey about the last vignette you presented. Obviously, you appreciate that you and other scientists have a lot of demand on your time. So I'm wondering if you could get a little bit more into how you identified papers on bioRxiv for this project and how you sort of convinced, for lack of a better word, other people to serve as reviewers.
Yeah, so I guess I would say the pitch to the editors, so the other associate editors, was, and the reason I did it is because it's like, well, I get asked to review a lot of papers, but only the intersection of papers I want to review and papers that I get asked to review is not 100%. And so this is a way to make that number higher. I guess, yeah.
So in many cases, I think lasting change can come from a couple of different ways. There are certainly ways that could be top-down with mandates or from the community. And so given that you come from different stakeholder groups, is there any generalizations you can make in terms of your colleagues' views about some of these new initiatives like preprints or data sharing, or other initiatives and some of the incentives that you think would sort of make people more receptive to changes if they're a little bit uncertain about some of these new initiatives?
So in working from a lot of people, at NIH and also stakeholder groups outside of NIH, I think a lot of people see the data sharing or the reporting or submission of these interim research products as like one more thing that they have to do. And so they don't necessarily see some of this as a part of the scientific process. Anyone who's doing any type of research is, for most fields, is generating some sort of data. And what we want people to do is to manage that data responsibly and to share it responsibly, which should be a part of the scientific process anyway. And so I think for people who are either removed from it or don't want to share or whatever, they just sometimes don't see that it's a part of the scientific process and that it's something that they should be doing anyway.
So I guess I can say a couple. So I think one thing that I'd say is that as universities have moved to paying less and less of their faculty salaries, the potential good news is that funders have more of a role in determining what happens, so moving the field forward. So If a university is paying essentially 5% of someone's salary and funders are paying 95% of someone's salary, what a funder cares about matters a lot in terms of university promotion and tenure, in a way that maybe it didn't in the past when funders were paying 25% or less of people's salaries. So I think universities have sort of cost shifted, but also responsibility shifted, which I do think creates an opportunity for funders to then drive policy in interesting ways. So if I take off my pen hat and put on Alex's Lemonade Stand Foundation hat, we just rolled out a new data sharing portion of grants. So there's a page that looks a lot like a resource sharing plan from the NIH, except there's a couple subtle differences. So one is that you have to describe not only what you intend to do, but also what you have done in the past in terms of sharing resources and how those resources have been reused. And then your both past track record and future plans count for impact. And so whether or not it gets funded may depend in part on how well you have shared and how well you do share. And so I think these types of funder initiatives can potentially help.
Thank you. I will note that some of the conversations around openness transcend, more than just this idea of open science. It's actually just openness in general with the way that people work with one another. You see much more collaboration, and these collaborations happen in a much more distributed fashion now. So the collaborations can be international and regular and very productive. And what that requires is putting things in place to make it easier to share information, to share ideas, to communicate that. And I'm hopeful that that continues to challenge us to move forward in those ways.
Okay. So from your perspective, what 1 to 2 actions could you recommend that maybe some of the stakeholders in this room could do to make these developments common practice, either in the short run or long term? And that should be maybe incorporated into strategic plans as the theme of the day is new directions and strategy. And we talked about community and then, technology.
I was going to mention 2 things. One, I think the incentives issue is huge. I think, and a lot of times the people that are having the conversation on the importance of incentivizing are the people that are already sharing. So I think if the community can figure out a way to help funders and help their universities understand the importance of incentivizing or come up with some sort of means for incentivizing the sharing, I think that would be really, really important. The second one, as far as NIH is concerned, and I know I mentioned this earlier, but I cannot stress how important it is. If we release a request for information or a draft policy or something like that, it's extremely important for our stakeholders to reply to that and engage with us so we can hear what the community has to say, because it's very important in how we move forward with policies that would affect our stakeholders.
Okay, great. So I've got a couple of suggestions too. The first of these, and it may dovetail into the incentives comment that you just made, but is the idea of leveraging persistent identifiers and this idea of interoperability with systems wherever we can, because I think that actually goes a long way to reducing the burden for people to do the right thing. So make it easy to do the right thing. So make it easy to exchange data between systems, between the institution and your organization and things like that. And I think that there are some exciting ways that we're seeing that happen, especially with ORCID and other initiatives. The other one, and it's a bit self-serving, but I really would encourage anyone who's interested in thinking about contributor roles and their representation in research information systems, as well as having a broad conversation about what research outputs are today, how do we think about these, and how do we create an ecosystem that is flexible enough to evolve over time. We really would love to hear from you, talk with you, work with you, and have that be a very collaborative experience. And I think, part of the reason why some of these changes are so hard to make is because we've been doing things the same way for hundreds of years. And so what is a paper? What is a paper going to be in 20 years? Those are, I think, conversations that'll be interesting, and I look forward to them.
Okay, well, one of mine was going to be help your authors share well, but I make it easy for people to do the right thing much more, so we'll go with that one from Kristi. And then the other one I would say is, since there's a lot of publishers in the room, I would eliminate the data available upon reasonable request as a way for authors to share data. I think there's an excellent example from Jack Gallant where he published a paper in Nature and then someone asked for the data and he's like, no, I can't share the data. My postdocs are still working on it. And so this is all public on Twitter. I was annoyed enough that I went and FOIA'd his resource sharing plan. So I have the copy of both the resource sharing plans from both of his R01s that are cited in that proposal, or in that paper, and they essentially commit to nothing. They sound great, but they commit to nothing. And I would say I think people hide a lot behind data shareable upon reasonable request. And most of the time, if there's a reasonable request, I think they say no. So.
Well, thank you so much, Jenny, and our speakers today. Let's thank them all for their effort and time for being here.